Let me share my screen. So let me turn off the video. So software is getting slow. Yes, up to now we have stopped, right? Or else previously whether it had the session has ended. Up to this we have seen, right? How to model the basic thing. Yes, yes. Clear. Issue before this. Yes. So just I'm copying and pasting this source from the master library. Then the same thing for my transformer also. Then I had picked the bus from this components tab. In fact, of course, yes, this bus bar will also present in master library, but all other components which are present that we are ready to use immediately we are going to use, right? So those components will not be user friendly when we are going with master library. Each and everything will be present in separate libraries, separate tabs in the master library. So in order to avoid all those things, all the major components, major using components will be present in this components tabs itself, right? So now I had modeled this, a simple network. So to interconnect this, I'm using this wire mode, right? Wire upon pressing the wire mode, start with left click and end with right click, clear. To get rid of this pencil mark, just press escape. So in case if you are drawn excessively means just select and delete. So if you want to delete any component means just select on that component and press delete. Clear? So just delete option. It will not store any other backups of this. Just delete that transformer. Clear? So in here, I think to connect elements using wire mode, right? So components tab for major using components. Instead of accessing the master library each and every time, then orientations to rotate everything, just press R, mirroring M, flipping F, left rotation L. These are the shortcuts. Then for wire mode also, there is one shortcut. If you place on that itself, it will be showing Control plus W. So Control plus W will permit you to allow use the wire mode, right? So this is how you should model using this wire mode. So if I want to measure anything means, right? If you want to measure anything, for example, this line current I want to measure, or else this bus voltage I want to measure. Yeah, anything means. So there is a individual meters called. See here, let me classify. This is current. This is voltmeter. This is voltmeter. This is multimeter. Right. So this current meter, which is ammeter, that is the term used in PSCAD is current meter. So this current meter will measure the current flowing through this. Right. If I'm placing like this, it won't work. I want to just move this wire mode, place here. And once again, I want to select wire mode and compile with this. Clear? So like this, if I want to placing this meter means I can able to measure the current flowing through this. Then voltage, if this bus voltage I want to measure means, so I cannot able to place here directly like this, right? So let me rotate and place here. So both are the same, voltmeter are the same, whereas this is voltmeter to ground, this is voltmeter alone, this is ungrounded. Mostly we will use this grounded only. If it is like congested, looking like congested means just extend the bus size and place here. You can extend the bus size by pressing this either this green or blue. Clear? In both the sides, you can able to extend the bus length. So after this is multimeter. So voltmeter, you might be aware, which will be measure only voltage. Current meter, you might be aware only measure it will current. Then multimeter, it will measure all the things. See, instantaneous voltage, instantaneous current, active power flow. Just yes. So in here we will be measuring. Yes, I haven't speak. Just now I am speaking. So instantaneous voltage, instantaneous current, active power, even reactive power, RMS voltage, RMS current, phase angle. So these things can be measured using this multimeter option only, right? This is the specialized tool here which we can able to measure all the parameters that are mentioned here. Clear? So usually in other softwares, how you will measure the things upon running the simulation itself in the bus bar, the loading percentage will be occurring, right? The voltage loading will be occurring. The real power and reactive power will be occurring, right? But in PSCAD, it won't be appearing like that. So for measuring also, we want to do some customizations and some separate tool options to measure and to view the graph also, we want to do some external applications, right? So now let me show you how. So hope you understand, right? For example, why I'm insisting ETAP means, so basic tool actually ETAP. So from there, if anyone who is starting with power system studies, so if he can start with ETAP means it will be more easier to understand all other softwares also, right? So in PSCAD, if you are running the simulation means nearer to the bus itself, the voltage loading will be occurring. It will be showing, right? The real power, reactive power flow. Whether if you want in terms of power factor and current, that also will appear. So like that, it will appear. But in PSCAD, what we should do is, see now, I have placed the three different, but now let me show this multimeter option alone first. Now I want to measure the instantaneous voltage and instantaneous current of this bus bar, right? So let me enable this. So in here, viewing results and measuring. Viewing results and measuring. So here the steps is not bit complicated, little elaborate, right? So when, for example, now first what we should do is we should call a signal first. Then we should give that signal to the channel, right? First we should call a signal. Then we should give the signal to the channel. So from the channel, we should extract the graph. It's a sequence line like structure, extract graph. Clear? So before that the signal can be defined inside the multimeter or direct current or voltage meter. Current or direct in ammeter or voltmeter, you can measure. So now in the multimeter, so upon enabling here, yes and yes, in this configuration tab, I'm enabling. Then now I'm going to the signal name. right? It is showing alone, these three alone will be getting enabled. Now I want instantaneous line to line voltage. So I'm naming here VLL. I'm just naming. So I'm giving a signal. Then I instantaneous current. So let me give INS. Okay. Now I'm clicking OK. Then now first step what I said. So signal, you want to first mention the signal's name. After that, you want to call the signal. So first to mention the signal, then only to call. So first to define the signal. So first to define the signal, then call the signal. So now we have defined the signals VLL and INS. Now let me call the signal. So how to call the signal is in the data and output, there is option called signal here, right? A small dot like structure called signal. Two signals I want to measure. So two signals I have called. So the name, exact name what you have given here, that you should copy and paste here as the signal's name. Clear? So how I'm changing is just to double click on that signal. By default, it will be having the name as SIGN, right? So here I want to measure the current now, INS. Clear? So after calling the signal, what is the step? Call the channel. Why? Because upon calling the channel only, we can able to measure the waveforms. So where to call the channel means nearer to this. This is signal. And coming to here, the first option is the channel. Right? A box like structure. Once again, I am plotting. Clear? These are my channels. Now I have to connect these two. As usual, our wire mode, starting with left and ending with right. Starting with left and ending with right. Right? Whether this alone will permit you to measure the values means no. So the final step is extract the graph, right? Extract the graph. So how to extract the graph? So in the value, so in this channel, just right click on this. There is option called graphs, meters and controls. In this select this option, there are various graphs. So for us, which will be suitable is add overlay graph with signal. Whatever may be the study we are performing, we will be using this graph only. This is for value 1, right? And this is for value 2. So for value 2, once again, the same procedure. Graphs, meters, control, right click on that. Overlay graph with the signal. Yes. Now the steps, I think we have matched, right? Defining the signal, first one. Calling the signal, calling the channel, extracting the graph. After that, you should run the simulation. So now let me perform the simulation. So perform the simulation is nothing but, as I mentioned before, just click on this run. Right? There is no specialized tool at all. So it starts converging. And sometimes this like permission will appear due to your firewall properties. So at the time you should press allow. You should not cancel. So some of the system it won't appear. Why? Because your firewall will allow those things. If your firewall won't accept means you just press allow. Right? So now you can observe here EMTDC run completed. Right? Run 1 of 1. So run completed means you can check the status of the run by here only. See, it is not, sorry, it is showing run completed. So now that's all. Whether you have observed the results, expected results means no. Absolutely no. Reading the graph itself, reading the graph will have some formulas. Sorry, some steps that I have mentioned as formulas. So reading the graph after simulation. So after simulation, reading the graph, the first step is to reset the graph. So reset the graph. Shortcut is select the graph and pressing R. So after resetting the graph, measure values, by M. Reset the graph and measure the values so that you can able to observe the graph. So now after running the simulation, let me select on the graph and I'm pressing R. After that, I'm selecting on the graph, I'm pressing R. Clear? Why? Okay, now let me zoom in. Just for zoom in, select like this. Hope it is visible, right? Yes. I want to measure, right? Measuring means M. Bus to current is not possible. Yes, of course, it is open in nature. So only it is showing nearer to zero only, right? So only bus is, let me give this signal, IA1. Now let me run the simulation. Press run completed. Let me reset. So here also current is flowing in the form of 0.0040, whereas the terms is ampere, kiloampere. Here also our voltage is flowing. So where we have seen in the both the case, we are seeing the instantaneous. If you check for RMS means, that is per phase means voltage that is flowing in a single phase and the current flowing through the single phase alone, it will be visible. As of now, we are plotting the instantaneous. So, so actually this signal is consisting all the three, right? Upon zooming, it is visible, right? R by B, the same in this case also. It is visible upon zooming only. But if you plot for RMS, separate RMS will be appearing here, right? So first how to reset the graph, measure the values. For measuring the values, just press the M. So by default, it will be by pressing R, it will be like this. I'm pressing M. So here some sliders was appearing, right? Hope it is visible, right? X and O marker. Let me try to zoom the PSCAD. Yes. Here X and O marker is there where it can be movable. So this can be brought here by. So if explaining this option graph means alone, there are various options here inside, right? See here, all are basic only zoom in, zoom out, resetting the x-axis, resetting the y-axis. This is complete reset. So instead of this reset only, we are pressing R. This is previous zoom. This is forward zoom. For this also, I'm just zooming here. Let me show you. I'm zooming here, right? Now I want my previous zoom ins. I want to press here. Clear? Next zoom ins, I want to press here. In zoom also, for moving forward and moving backward zoom, we can use this. Finally, for measurement, this toggle markers option, which will be used for measurement. It can be brought by pressing M directly or else using this option also. For resetting, this option we can use. Instead of pressing R, you can use this or else you can use this, pressing R. How to go to that options at all means in the graphs, in the corner, some arrow triangle like option marker is there, no? So click on that, you will get all these options. So major shortcuts are R and M alone. For resetting R, for measuring M. So now check the value, maximum 325.106 kV, right? In forms of kV. Why? Because our source is containing the source we will see in detail. The source we will see in detail, right? So let me show. Source is 230 kV. Then it is showing a 325 voltage. The which bus voltage I am measuring? VLL, bus 2's voltage. How it is showing 325 means actually our PSCAD will always support per phase peak value only. So 230. So 230 is per phase values divided by root 3. And if I want peak value means per phase peak per phase value into square root of sorry, square root of 20. So I think the transformer rating is different here. 230 is in LV also it is 230. Okay, we are not measuring the peak value, but we are measuring the line to line value. Right? So this won't work. Mm, 400 kV system, whether it is. I still think so. Okay, let me explain this graph after the source modeling. Yes, now, but whether it is clear now how to reset and how to uh, check the values, right? Starting using this toggle markers only, we can able to check the values. If you don't need this toggle marker means just select the graph and press M, the toggle markers will disappear, right? But other than that, in the external, it will not show like in other softwares. It is showing the answers directly, no, right? So directly in terms of in the bus bar itself, whether it can be viewable or not. So those things we cannot able to view. Like this, we want to do, right? Okay, changing winding, unable to run. This is bus 2 is not possible. Enable instantaneous current. Run the simulation. These both are RMS plots. Yes, of course. Yes, yes. I haven't changed any parameters in the elements. I just copied and pasted here. But upon performing our simulation, we want to change. We must want to change. Yes, yes, Ibrahim, I understand. Actually, in here we haven't done the per phase, right? So 230 into root 2. I captured right. 230. So 230 into square root of it. Yes, 325. It is what. Can you repeat calling again? Just calling part. Can you please explain here about solution type step and channel plot step? Yes, yes. Or your question. So for measuring channel plot step means I think some of them haven't aware about calling. So for calling the signal, first inside the multimeter, what are the parameter you are going to measure that you must enable first. So by default, everything will be no. In here, I just enabled the instantaneous voltage. In the bus 2, current will not possible. So let me disable that. So let me enable instantaneous voltage. After enabling, we want to define the signal, right? In the signal, for us, I mentioned enable the voltage alone. So these two alone get enabled for me, phase voltage and line voltage, right? So in this, I am defining the signal. The signal must be unique and the same steps can be followed. It must not be start with alphabetical, but it can be alphanumeric, but it must not start with alphabetical. Only thing we should use is underscore alone. Other than that, we cannot use any other special characters. So let me give VLL. Capital and small letter is not an issue, right? You can use capital and small, whatever you need. So after this is for first step defining the signal. So after calling the signal in the components tab, you should use this component called signal. It will be appearing like this. After that, you want to call the channel first. That will be present in the components tabs alone. So nearer to the signal alone, it will be present. So after this, you want to change the signal's name. What name you have given inside the measurement, the same name you must enter here. Why? Because it is case sensitive. Even if you are entering in smaller caps, that's not an issue, but you should enter here. Clear? So after entering, just connect using the wire mode. That's what I done here, right? After doing this, you want to plot, right? So for plotting alone, this is not enough. From this channel, right click on that channel. There is an option called graphs, meters and controls. So there are various graphs available in here. But for our convenient, for all other studies, we will be using this overlay graph alone. That's what this graph. Clear? So after this graph, if you're placing this in the workspace, you can run the simulation from Home tab by pressing this direct run. So the simulation will be converged. In case if there is error, it will be showing some errors in the build messages here, right? So here it is already showing some error. I hope so. No, it is not showing any error. If it is showing error means a pop-up will appear. Simulation cannot be converged. So if it is proper only, our simulation will be converged like this. Clear? So this is in case of multimeter. But in case of this voltmeter and current meter, this name also can be changeable, right? You can change this name, right? But as of now, it is a new tab. It is a new workspace. The signal is nowhere used in this tab. So I called this current signal IA1 and given to the channel. And from the channel, I'm plotting here and checking with the current. For measuring, let me press M. Two markers, toggle markers will appear. Using that markers, I can able to measure the value, current value. Clear? So solution time step I mentioned before itself, that is not a part of the channel time step, right? That will each and every 50 microseconds, it will how to say, it will make the mark the solutions. The solution will be plotted at each 50 microseconds, where a channel plot step is 250 microseconds. If you are changing the channel plot step like this, so I'm zooming in and in, right? So if you're changing this channel plot stuff, the simulation speed will be fast. Let me give 2000. Let me run the simulation. See here, the same only, but in the previous case, what value we got? 325.466. But in here, channel plot step, What it will do is channel plot, what actually it is doing is, if it is 250, right? Let me create a, so if it is 250 microseconds, at each 250 microseconds, for example, let me consider at each 250 microseconds, right? It will be plotting the channel, right? And your accuracy is quite more, the same as the solution time step only. Each 250 microseconds, it will be plotting, right? But when you place 2000, so starting from here, another 2000. So here 2000. The channel plot step will plot 2000 at a case. The same for solution time step also. For giving 50 microseconds means each and every 50 microseconds, your solution time step will be plotting the graph, right? If you are increasing this, your solution will also be accurate, not accurate, approximate only. So if you are plotting, like it will be plot here, it will be, if you are extending like to 200 or 250, it will only plot up to 200 milliseconds, microseconds once. So this is how channel plot step will work. Usually 250. If you want to enter your customized value means also, that's not an issue. So upon entering 250, now check the value. Our simulation is completed now. So now check the value. It is 325. It is accurate. Clear? Yes. Thanks. Interest current. So for seeing the interest current, that is what now we are observing. So transformers HV side, I am including this IA1. So the current what we are measuring now is actually the interest current, right? Before that, we want to include a breaker and we want to suddenly close that breaker so that the action will be acting like energizing the transformer from new. But in here, it is directly connected to the source. The thing current what we are measuring in the transformer's input, incoming feeder, that is inrush. Like the sampling rate, maybe we can, that is not like sampling. Yes, we can say it is like sampling rate. Whatever microseconds we are entering, during each that microseconds, our we will be having the solution time step and channel plot step. So Saravanan, you are, I understand you are trying similarly parallelly with me, but it will not work in the live session, right? So you can try and you can grab all your doubts as a document and you can post in the group or you can send to me directly. Let me answer those things, right? Why? Because in the live session with 60 members on board, if you are trying parallelly, I cannot able to match with you, right? Secondary versus VLL, can we change the scale of X or Y of any choice? Call it, please reframe. It is a bit difficult for me to understand. Secondary versus VLL. So which value of microseconds is recommended for accuracy? Yes, Ramona, in the previous itself, I have mentioned, right? So depending upon the study, what you are performing, right? How to get the equipment's real data? Simply from the client, we can able to get the real data, or else from the OEM. Usually, client will have all the data, or else if you want more detailed data means we have to ask the client to reach out their OEM and get all those data, right? I think the time is going to, meeting timer is going to end now. So as of now, whether everyone is clear, right? So how to um, plot in PSCAD, right? How to plot in PSCAD? Yes. So first step is to you cannot plot directly. First step you should define the signal. After that you have to call the signal. After calling the signal, you have to call the channel. After calling the channel, you have to call the graph. Right? This is actually a sequence like structure. After doing all these four only, you can able to see a graph in PSCAD. Yes, partially. Yes, after the lunch, we can discuss in detail, right? What are the typical data sheet to be asked from the client or OEM? For which element you are asking Trilokan? For whatever may be the elements we are modeling in PSCAD. So all the elements we want to get the data from client only. Yes, whatever may be the elements you are modeling, same, the typical data, uh, breakers, everything you are mentioning, right? So those things will be asked from client only. So that in detailed modeling, I will explain. So what are the data to be asked from the client? What are the data to be asked from the OEM? That I will explain in during that transformer everything. Yes. So OEM means we cannot able to reach the OEM directly, right? So usually we will be able to uh, raise the concern, what we need input, concern input to the client only. If the client is not giving the data, having the data, they will automatically reach their OEM simply. The system engineer, those who's performing the studies cannot able to reach the OEM directly. Requirement of parameters will be mentioned by the system engineer. System engineer will reach to the client. Client will reach the OEM and they will provide us the data. Yes, many case you are the client means then you are responsible to ask with the OEM. In case if your engineers is asking for performing the studies. Yes, up to now, result graph viewer and signal channel usage, we are aware. Actually, this is like an version. Even if I can able to explain the graph option alone nearly for 1 hour. That much options are there in graph alone. But for basics, that much detailed explanation is not required. Just you want to know what is this software and what is the difference between other softwares. So for that, this much detailed explanation of that graph alone is not required. Even in the ribbon control bar also, it can be take up to 1 hour for each and every option how to discuss. Right? But time concerning, I'm cut shorting everything and what are the things to be needed and what are the things to be covered within this 5 hours. Let me exploring all these things. Right? So now let me